This is the sixth CNC lecture of CAM 810S. It is an introduction into CNC milling. The topics: machine components, coordinate systems and points, types of control, milling cutters, tool holders, and tool changing systems. This is Concept Mill 105, the CNC milling machine at our laboratory. For details, please study and discuss page 29 of the machine description. Identify and discuss components on the machine after this. In vertical milling machines, the Z-axis is vertical. Remember that the Z-axis is the main feed axis. In horizontal milling machines, the Z-axis is horizontal. To determine the coordinates of Concept Mill 105, imagine yourself staying in front of the machine. Applying the right-hand rule, X plus points to the right, Y plus away from you, and Z plus points upwards. This diagram shows also the working area of the machine. 200 millimeter in X, 150 millimeter in Y, and 150 millimeter in Z. Let's now analyze the points on a CNC milling machine. The symbols are the same as on a CNC lathe machine. Remember that the red color is usually replaced by white color. R is for the reference point. M for the machine 0 point. T for the tool reference point. And W for the workpiece 0 point. For points on Concept Mill 105, study and discuss page 30 of the machine description. Identify and discuss the points on the machine. As in robotics, there are different types of trajectory control. Point-to-point control is employed only in CNC drilling machines. In linear trajectory control, the feed is only possible parallel to the axis. Only one axis moves at a given time. In 2D continuous path control, circular interpolation can be done in one plane only. Two axes move at a given time. Whereas in 3D continuous path control, all three axes may move at the same time. 2.5D continuous path control is somewhere in between 2D and 3D control. Circular interpolation can be done either in the XY plane or in the Z plane, in the ZX plane, or in the ZY plane. Plane selection is programmed with G-codes with which you are going to get familiar in programming practice. Before we proceed to the different types of milling tools, we recall some basic information. Main cutting edge of this shell end milling cutter is the one on the periphery. The corresponding surface is the main relief surface. The secondary cutting edge is at the face of the cutter, and the corresponding surface is the secondary relief surface. The rake surface is the surface on which the chip is formed. The meeting point of main and secondary cutting edge is the cutting edge corner. The angles are alpha, clearance angle, beta, wedge angle, and gamma, rake angle. Alpha plus beta plus gamma equal 90 degrees. The tools which we employ at Concept Mill 105 are NC start drill, a short twist drill with a point angle of 120 degrees and a diameter of 10 millimeter. The edge tracer is not a cutting tool, but it is an auxiliary tool, which is used to determine the X and Y position of the workpiece. There are several slot milling cutters with two face cutting edges, which can be fed into the material along the Z axis. There are several heavy-duty shank and end mill cutters with four main cutting edges for milling in X and Y direction only. Radius cutters of this type are used for milling of convex grooves. With this angle cutter, dovetail profiles can be produced, whereas the last one, the 1833, is an angle cutter which is used mainly to produce 45-degree chamfers. Bores of relatively big diameters may be produced with this tool. This is a shell end milling cutter with combined roughing and finishing teeth. Its diameter is 40 millimeter. This staggered tooth side mill cutter produces slots of 5 millimeter breadth. There are twist drills of several diameters, and the center drill may be used instead of the NC start drills. Taps are used for thread cutting. Milling tools are clamped in tool holders. They must meet the following requirements: high radial accuracy, that is also called run-out accuracy, high axial accuracy, high rigidity or stiffness. They must be suitable for high RPM. and the time for tool changing should be short. There is quite a big variety of tool holders on the market. Let's first analyze the tool holders for Concept Mill 105. The tool holder has a self-releasing steep taper shaft. A draw bolt clamps the tool to the spindle. The milling cutter is clamped on the mill holder. This tool holder is used for shell end and side milling cutters. The cutter is fixed with a lock screw. Radial forces are transmitted with a parallel key. And mill holders come in different standardized diameters. For cutters with a low height, washers must be used. This tool holder is used for cutters with cylindrical shafts. The cutters are clamped with 2 screws, position 3. The ESX16 collet holder is also used for cutters with cylindrical shafts and for drill bits. Radial forces in both holders are limited. For heavy-duty performance of cutters with cylindrical shafts, the Weldon system is indicated. Weldon cutters have a flat surface to which the locking screw is fastened. The V-groove is explained later. This is a generally used standardized steep taper tool holder. Its draw bolt is interchangeable. This holder is equipped with a collet, and the V-groove is explained later. There are several standards, among them SK, DIN, German standard. Its taper is 8 degrees and 45 minutes. BT, which is a Japanese standard, and CAT, which is a US standard. Another widely used tool holder type is the hollow shaft taper tool holder, short HSK, which is also a DIN or German standard. More information is given later on. Steep taper tool holders are clamped to the spindle by a draw bar, which engages on the draw bolt. For clamping, the drawbar moves up. For releasing, the drawbar moves down. The hollow taper HSK has got a different design. Its taper of approximately 3 degrees is also self-releasing. Mark that the wall of the taper is relatively thin. After inserting the hollow shaft or hollow cup taper to the spindle. Outside and inside taper match, but there is a small gap in axial direction. When the drawbar mechanism moves up, a collet engages in the hollow shaft, expands and clamps the holder tightly to the spindle in both radial and axial direction. Please watch the YouTube videos which show both systems. Let's compare the two systems. The steep taper is an outside clamping device. It has a relatively poor stiffness, a good or fair radial accuracy, but a poor axial accuracy. It is not suitable for high RPM. The stroke for tool changing is relatively long, but steep tapers are widely or commonly used because of its moderate costs. The hollow shaft or hollow cup taper is an inside clamping device. It has an excellent static and dynamic stiffness, an excellent axial and radial accuracy. It is highly suitable for high RPM. It has a low mass. The tool changing stroke is short, low, but it is clear that it is much more expensive than the SK system. This steep taper tool holder is of the centered through coolant type, for which the spindle must, of course, also be especially designed. Most CNC milling machines have automatic tool changing systems of various designs. Concept Mill 105 is equipped with a tool magazine which holds up to 10 tools. The tool magazine is situated in front of the Z-axis. In other machines, the tool magazine may carry 24 tools or 40 tools or more. Tool changing systems, here for SK steep taper tool holders, are equipped with a mechanism with a double gripper which engages in the V groove of the holder. Please watch the YouTube video after this lecture. Finally, a few information regarding part clamping, which can be done in many ways, but always suitable to the part. Concept Mill 105 is equipped with a pneumatic vise for automatic clamping. The clamping force is adjustable. For heavy-duty milling, parts must be clamped accordingly. This is a hydraulic vise for high clamping power. The movable jaw clamps the part against the fixed jaw. This vise is mounted on a swivel base and both jaws are movable. Large parts may be clamped directly to the table with clamping jaws. This is the end of CNC 6 lecture. Please watch the YouTube videos and to do the exercises. Thank you.